Hello, my name is Fernando. I'm a solutions engineer at Replicated, and in this video, I'd like to give you an overview of replicated COTS. So let's get started. Replicated COTS allows you to package your Kubernetes application and deliver it to your customers whether they have Kubernetes or not. In the case of customers that don't have Kubernetes, replicated COTS allows you to embed a Kubernetes cluster into a VM. So your end customer would only have to provide you with a Linux host. If your customer already runs Kubernetes on the cloud or on the on-premise like OpenShift, you can also deploy COTS into that environment as well. To do that, we provide two sets of tooling. One is for you, the vendor, that allows you to package and operationalize your multi-prem deployment options. But there's also tools for your end customer, the administrative tools. So think of the corporate IT admin that installs your applications and does upgrades, backup restores, and things like that. So we also have a set of tooling for the IT admin that I will show you in just a moment. But let's start with the vendor tooling. So let's switch over to the replicated vendor portal. And in the replicated vendor portal, and here you can see I have my application. So my demo application is Sentry Pro. It's an open source application that I've put into COTS. And I have my channels. And these channels allow me to manage who will have access to which releases. So in my stable channel, as you can see, I have a few customers. I have a release in here that I have promoted. But you can create as many channels as you'd like. Many customers will have various channels for their various release branches and so forth. A release in Replicated is a set of Kubernetes deployment artifacts. So in this case, I'm talking about Kubernetes manifests. So here you see two sets of Kubernetes manifests. The ones below the demarcation line are the ones required to bring up my application. In this case, as I mentioned, is Sentry. The YAMLs above that line were the ones for you to configure replicated features like support bundles, pre-flight checks, and things like that. You can also use a Helm chart. So when I talked about Kubernetes deployment artifacts, you could also be a Helm chart. So here's a release where I use a Helm chart to create a release in Replicated. And again, as I mentioned before, those YAMLs that you see above the demarcation line are for replicated features. So once you have your channels, you have your releases, the next thing you need is a customer. So in Replicated, you can come to the vendor portal and create a customer license. Now the license, it can be about entitlements. It can also be about security. If you're using replicated COTS to deliver your applications, that means that we'll have access to your private images. So the license allows us to verify that your end customer should in fact have access to your private images. But you can also do things here like toggle on and off certain replicated features. For example, whether your customer should have access to air gap bundles, do they want to update your application via GitOps workflow, and should they use our backup and restore feature for data disaster recovery. You also have the ability here to add custom fields. So if you're already using another system for entitlements, maybe you already have a license key generator, you can create an external license field and track it that way. So for our demo, we're going to download this file and we'll use it in our deployment. Let's go back to the channel screen. So in the case where we're delivering to a customer that doesn't have Kubernetes, that is when we would do the embedded cluster model, right? So in the embedded cluster model is where we'll install a one node cluster into the VM. But keep in mind that you can bring other VMs to the table. So if I had a customer that just has a VM, under install here, I would select embedded cluster. And this command is what they would run that you see below. It would run on the VM. Now, on the channel, you also notice there's a Kubernetes installer. And what the Kubernetes installer does, it allows you to write a spec of what that Kubernetes cluster is going to look like. Should it use OpenEBS for storage? Should it use Minio if we need S3 compatible storage? If you go to curl.sh, curl with a K, you'll see that several add-ons that we support and the specific versions that you would want to put in here. In a production environment, your Kubernetes installer would likely have specific versions in there. But let's go ahead and run an installation. So let's start, we'll start one with on a VM. So I have a Linux Ubuntu image up and running. And I'm going to take this command over here and I'm going to run it on the VM. Now with the special effects of the video, I'm going to speed this up a little bit. It may take 10 minutes or so to run. So, but here I'm going to paste the command. Let's get a new screen here. Okay, so what you're going to see is it's going to start to download all the various packages that it needs to install the one node cluster, right? A primary node for Kubernetes. In an air gap scenario, by the way, it would just be an air gap bundle that would contain everything. So you would just untar the bundle and then run the script that's on the root folder. But here it's an online installation, so it's downloaded all those packages. It ran pre-flights on the Linux host to ensure it had all the necessary things. And now it's going ahead and installing Kubernetes, initializing the cluster. And once it initializes the cluster, it'll start installing all the add-ons that we specified in that Kubernetes installer. So here we can see Weave and others are getting installed. So once it's finished, it looked like this. So your end user, once they install your application using Replicated, they would come here and they would see they have an installation complete message. They will have a URL for the COTS admin portal, and they would have a username and password. And there's other useful information like adding other nodes. So that's in case you want to have multiple nodes. Now, if you had an existing cluster, then your end customer would just install a kubectl plugin, a COTS, and then they would run a kubectl COTS install to install the application. The second process would be a lot quicker because now we're not installing Kubernetes, right? Your end customer provides you the Kubernetes cluster, and we're just simply installing into a namespace. In this case, the address is a little different, it's localhost. But I'm going to connect to the instance installed in the VM. So the first thing you go do is get a TLS warning, and this allows your end customer now to secure the connection, because now this allows them to update their your SSL certificates and provide the domain and so forth. Now for the demo, you're just going to skip and continue. We'll keep the connection unsecure. Keep in mind that also COTS ships with a self-signed certificate, which you can also leverage in your application. Once you log into the admin console, we're going to install the license that we downloaded. And this is just going to verify the channel that I'm entitled for this application. And any information in that license file can be fed to the application via a config map. Next, you'll get some config options. So by default, this window is empty. As you get to decide what fields get to go on this screen, we provide you with a custom resource definition object that allows you to define which fields types are allowed, and you can use that to create a screen to gather the information you want from your end user. You do that all in a deployment manifest. Then you can take that information and feed it to your application as a config map. It can be an environment variable. You can fit it to the pre-flights that we're running right now. So one of our examples was a Postgres database. If you wanted to connect to an external Postgres, we could gather the information from those fields and then pass it to a Postgres check that then can connect the connection. The pre-flights are part of our troubleshoot.sh project. And as part of troubleshoot.sh, you have analyzers and collectors and redactors. The analyzers is what you're seeing right now. Analyzers have results that pass, fail, and so forth. And then you can check conditions, and then if they don't meet, you can fail it and provide them with more information. So in this example, we had a fail count on the node count, so we can link to an article on that. So this allows your end customer to be much better empowered, to be able to ensure that the environment meets all your requirements before they deploy the application. This eliminates a lot of the early support tickets you may get when folks install applications without reading the instructions. We all do that. We're going to go ahead and continue. Let's say we address the issue so you can continue. And now what you see on your screen is the COTS admin console. So this is what the IT admin at your customer would use to manage your application. So from here, for example, I can check my updates. I can configure how often I want to check for updates. So this would mean new releases promoted to that channel. I can come back here and we can edit any of those config options that we provided at install time. So we may want to change some of those later. That is supported. As part of the troubleshoot.sh project, not only can we do pre-flights, but we can also do support bundles. So with support bundles, you would set those collectors and analyzers to run when something goes wrong, right? So your IT admin may get called from their user base that something is wrong with your app. So the first thing they would do is come here, run a support bundles. The first thing your support team would tell them, right? If you have any issues, the first thing you do is come to troubleshoot, generate a support bundle. In the support bundle, you get to define in a YAML manifest what collectors you want to run. For example, you may want to collect pod logs. You may want to grab some files from inside a container. You may want to exec into a container and run a command and grab the output, or may even want to run your own script. You can always put that in a container and run a pod. It will perform some action. And then you can have analyzers, right? And analyzers, like in the pre-flight checks, can check properties of the cluster. can check the output of those collectors. So for example, if you have a collector that runs a pod or execs into a pod and runs a command, you may want to run a regex on the results of those commands. And then the analyzer can come back with a pass or fail. Maybe you're looking for a specific error message that you know that whenever that shows up in a log, it means something, right? So you can have a regex that looks for that specific string. And then once you put it in an analyzer, you can display to your end customer in tiles like this. So the two tiles that you see are for errors and warnings. So you can surface to your IT admin at your customer issues this way, and they're able to see what they may need to do to resolve these. Now, if you uncheck that box, now you see all the other analyzers that did pass. Your IT admin can also come into the file inspector, and this is where you see all the collectors, whatever the collectors collected. So in this case, we have logs from the Sentry application as an example. But your IT admin could then make sure that the Rector report removed everything that is sensitive, and then they could download this support bundle and ship it to you. And you're able to upload this into the vendor portal, and Replicator is more than happy to assist you in diagnosing the issue, especially if it's related to COTS or to the cluster that we deployed. Back to the admin console here. So there's licenses where you can update your licenses, but the other options that your admin could set up here is they could use GitOps to update their application. So when there's a new release, they could do a commit into a repository and use their pipelines to deploy your application. And there's also the ability here to add more nodes. So in this case, it would be another Linux host that I would bring another VM, and I could run this command and start a multi-node cluster. Our snapshot leverages Velero for Kubernetes native snapshots. This allows you to configure probably an offsite storage, not in the same VM or in the same cluster, like Amazon S3 or a blob storage in Azure and so forth. And this allows you to have backup and restore. So this captures not only your application state, but also the COTS state. So if your customer has a catastrophic event, this would allow them to restore COTS and your application in a new cluster or a new VM. Well, that about wraps it up for us here. If you want to learn more, go to www.replicated.com. Thank you. Goodbye.